I recently recorded a video on sprite stacking in GameMaker, which is a trick that you can use to make a series of 2D sprite images look like a 3D object by just drawing them as ordinary 2D objects offset in a particular way. And towards the end of that video, I mentioned that there was a subject that was tangentially related to sprite stacking that I'd like to talk about, and that is what you see on screen before you. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about 3D ground fog. Now, before we get started, a few important observations. One, this is very much not the same thing as the Silent Hill-esque distance fog that you're probably used to dealing with in 3D, where objects that are farther away from the camera just fade out to a certain solid color. Distance fog is usually one of the first things that you learn about when you start getting into 3D and pixel shaders and that kind of thing, whereas the ground fog effect that we're going to talk about today is going to be localized to the ground that the player walks on. It is not going to attenuate or strengthen with distance, and it is also going to be a much more intermediate level 3D shader subject. 3D shader subject. I definitely just had to say that line like 7 times before it came out sounding correct. Now, as for exactly how intermediate this effect is, this is definitely something that you're going to want to be comfortable with shaders with, but in particular, you're going to want to be used to using shaders and using color values in shaders to represent something that does not necessarily correspond to a color on the screen. What we're going to do today has at least some things in common with sprite stacking, like I mentioned at the beginning of the video, but once we start writing actual shader code, it's going to deviate pretty quickly. And lastly, before we begin, there are other ways that you can implement ground fog in games. I've seen at least one other major, and I think 2 other major approaches to doing this, both of which perform a little bit better, but both of which are quite a lot more math intensive. We should be through implementing this in about 20-25 minutes, but I will also be spending a bunch of time talking about performance at the end. So, this is what we're going to have by the end of this video. This is based on my my good old Diorama 3D sample project from about a year ago. Anyway, you don't have to use the Diorama 3D style if you want to make use of this kind of a ground fog effect. I just think it looks particularly good in that kind of environment, and I just happen to have sample projects set up like that ready to go. So if I were to actually go into the project I'm going to be working in today, if I run this, it's going to look pretty much exactly like the what you saw at the beginning of the video did, just without the fog. We're going to be starting from here. I can zoom in with the mouse wheel a little bit if you want to get a closer look at something, or if you want to get a bird's eye view of the whole scene. You're not going to have to worry about exactly how this works if you want to follow this video, although if you do want to learn more about what I like to call the Diorama 3D style anyway, I've made a video on that. Let's see, I'm going to start by going into Photoshop or whatever image editing software you want and generating some cloud noise. I've done this ahead of time. This is just boring old cloud noise with the contrast dialed up a little bit to make it a little bit more visually interesting. We're just going to use a static texture for this. It is possible that you can create a more dynamic, flowing cloud texture that you can use with this, and you can even make it do fancy things like reacting to the player if you'd like, but I think that's going to be a subject for some other video. It is kind of fun to do, and I would like to do it someday, just not today. I'm also going to set the sprite origin to the top left, and I'm also going to throw this on a separate texture page. Strictly speaking, you don't need to do these things, but sprite origin at the top left is going to be useful because I'm going to be using boring old GameMaker draw sprite for this, and separate texture page is going to be useful because this is a 2K by 2K image, and if it's just left on the default texture page, GameMaker might downsample it for us without asking. Anyway, I am going to go into the draw event of the camera object, and the draw event of the camera object is, in this sample project, where pretty much everything visible is drawn, and indeed, probably about 75% of the time, if you're doing a 3D game in GameMaker, you're going to be doing something like this, where you have a camera object that dispatches the various draw calls to different types of objects instead of letting them all control their own depth or that kind of thing. There's a big philosophical debate in GameMaker about the best way to do that, but I find that this is usually the least amount of work. Anyway, after everything in the game world has been drawn, so all the like 3D diorama objects, 2D diorama objects, whatever, I'm going to first start off by going down a bunch of lines at the bottom of this draw event, and I'm going to say draw sprite SPR cloud noise subimage 0, and I'm just going to draw at 0, 0 the room origin. And this is going to cause this big honking cloud noise texture to be drawn just basically on the plane of the ground. And that's going to probably cause it to do a bit of Z-fighting. That's a little bit headache-inducing. Let's not do that. We can use a fancy function called GPU set depth to basically set the Z height of a sprite object when you draw it like this. If you set it to 1, it'll be drawn offset 1 unit on the ground. And it will be drawn above the tile layer, and it will not Z-fight. You could also use matrix transforms for that, if you're feeling fancy. So how do we take this image of cloud noise and give it the appearance of depth? So, I suspect there are multiple ways to go about this problem, but I'm going to draw not 1, but let's say var I equals 1, I is less than, like, let's say 16, I plus plus. Let's draw 15 copies of this this cloud noise sprite, one on top of the other, and I can on each go around I can say GPU set depth, and the GPU depth that I'm going to set is just going to be the loop index. So it's going to be drawn at depth 1, depth 2, depth 3, all the way up to 16 or 15 really. All right, fine, we can make it less than or equal to 16. By the way, the 3D camera in the scene uses positive Z as the up axis and positive X as the right-hand axis. If you're using a different coordinate system, you're going to have to shuffle some numbers around and do some fancy coordinate system transformations. But if you chose to use a different coordinate system for 3D in GameMaker, you probably already understand that you signed up to have to deal with a lot of coordinate system nonsense. Anyway, if I run this, we are going to have a... it's going to look a little bit like a lake. In a lot of ways, we're kind of like cutting our way through a solid sheet that's about halfway up our face. It looks kind of like, if we're being honest, like we're wading through a pond of very dirty water or something like that. You could imagine that we're going to get ambushed by, like, I don't know, some weird mutant alligator, that kind of thing. Anyway, our problem at hand today is how do we take this ground, fog, cloud, whatever texture, and how do we make it so that, for example, the brighter areas are going to be denser clumps of fog, and the darker areas are going to be less dense clumps of fog. And the way that we can do that, or at least one way that we can do that, is if we take the vertical height of each slice from 1 to 16, which is going to be this here, could make the font a little bigger, this here loop counter. We can divide the vertical height of each sprite slice by 16, by the maximum height. So we'll get a value between 0 and 1, or really practically 1/16 and 1.0. And we can map that onto the brightness or darkness of each pixel that we're sampling from our ground fog cloud noise texture. And we can say if the brightness of the pixel that you sampled from the texture is greater than our fractional height value, then you keep it, and if the brightness of each pixel is lower than the fractional height value, you're just going to discard it. So this calls for a shader. I'm going to create myself a shader. Let's call this SHD ground fog. I'm going to want to, let's say shader set SHD ground fog. GameMaker's autocomplete wasn't really working with me there. Shader reset when we're done. If I just do this, this is just going to be the GameMaker like default pass-through shader, and it's not really going to do anything. So I'm going to have to do a little bit of actual work to make this useful. Let's send in a few uniform float. Let's say U height, uniform float U max height. So we can set some uniform values to the shader every time we go to draw one of the layers of the ground fog. And we can say if, I'm going to get rid of this, if our height divided by our max height is less than the brightness value that you sample from the texture, you're going to keep the pixel. And if it's greater than that value, you're going to discard it. So first, let's say float, let's call it height fraction is going to be U height divided by U max height. I will slightly optimize this later. We can say vec for fog value is going to be texture2d gm base texture v underscore v text chord. To get the actual brightness of a color value, you can either do the fancy like luma calculation by multiplying red, green, and blue by the luma weights that you've often probably seen in shaders, or since this is a grayscale image, red, green, and blue are all the same value anyway. And I can just say float brightness equals fog value dot red. How you actually determine the color of this fog is up to you. And we can say if height fraction is greater than the brightness, then we can use the discard keyword, and that's going to just throw away the pixel that we're rendering. Otherwise, we can say gl_frag color, which is the output color in GLSL, at least our version of GLSL, frag color equals vec4, and I'm just going to make the fog white right now, so I'm going to make that 1, 1, 1, and let's say 1 on the alpha. I will get back to this later. So before I run the game, if we want to actually see anything useful, we're going to have to set these shader uniforms when we actually draw our layers. So we can say shader set uniform f shader get uniform shd ground fog, and our u_height is going to be just our loop counter, because that's the vertical offset that we're using when we draw each of these layers. And our max height is going to be, I'm going to hard code this to 16. I'll play around with this value a little bit later, once we see the effect working as it's intended. And now if I run the game, we should just have our ground fog in a very rudimentary, sort of lumpy sort of fashion. And for the most part, it just looks white. There's a few areas, like around the horizon, you can see that it's got a bit of a wavy pattern to it. It's not just a flat sheet. There are some sections like this patch down here, where you can see it's gone away entirely. Around the borders of trees, you can see that in some places it's a little higher, it's a little lower. You can see around the duck, like if I walk through it, you can see that it has a little bit of height on me, and it's not just like completely burying my face like it was when we started. But it still is very opaque, and when you imagine something like a ground fog effect, you're probably thinking of something that's got a little bit of wispiness to it, something that's that doesn't look like you're just walking through a massive pile of packaging peanuts. And to accomplish that, instead of giving the output color an alpha of 1, so again, fully opaque or fully discarded, we can give our output color an alpha value of, let's start with 0.1. I think should be a good starting value. And this is going to give us a much more cloudy effect. So again, if I zoom in, it might be a little bit easier to see. There are definitely denser patches and less dense patches. If I were to walk through, let me try and find a section where it's a little bit more dense. How about like down here? It definitely looks like I'm walking through a thick bank of fog or something like that. So maybe 0.1 in this case is a little bit like not opaque enough, a little bit too transparent. But there's a lot of values that we can mess around with here to tune the appearance of our ground fog to our liking. So I'm going to do something that I absolutely love doing in these demonstrations, and that is going to be to create a debug view. And this is going to, let's just call this fog properties. Let me set that to visible. And I'm going to, I'm just going to cut away. I love creating debug views in GameMaker. They make creating demos like this so much more fun. If you've never seen these, by the way, their debug views are DRIM GUI, and it allows you to create just debug interfaces that look like this. It's not something that you'd probably want to ship in an actual game, but if you want to just create a bunch of sliders or input boxes or whatever that you can use to test out things when you're like testing your game, they're great. Anyway, so there are 3 properties of interest to us when it comes to the ground fog. One is going to be the fog maximum height, so how far up off the ground the fog goes. The default value that I set of 16 is about halfway up our duck protagonist face. The fog layer alpha is fairly straightforward. This is still being hard-coded into the shader. I will make that a uniform momentarily. And the fog spacing, which is going to be affecting the loop counter update property here, the loop counter update value. So instead of just increasing it by 1, I can increase that by some other amount if you want denser or less dense fog. Let's start plugging these in. So fog max height, I'm going to want to set that as the uniform, and I'm also going to want to set that as the ending condition for this this for loop here. Fog layer alpha, I'm going to have to make that another shader uniform. We'll get to that in a minute. And fog layer spacing, so instead of saying I++ to increment it by exactly 1 every go around to the loop, we're going to set that to fog layer spacing. Let's see, I'm going to want another one of these uniforms for the fog alpha. So we can just set that here, and we can go into the fragment shader, and we can say uniform float u fog alpha, and we can take this, and we can set that as the alpha value in our gl_frag color. And this is going to give us a lot more control over how this ground fog effect looks. So for one, let me go into a fairly spread out area so that you can see the fog relative to like the duck sprite. If I were to increase the fog height, we're going to see that it's going to rise up much higher off the ground. If we set the max height to 32, I'm going to leave that at... Actually, I kind of like 32. I kind of like it when like the top of my head is just barely poking out through the fog. We can tune our fog layer alpha as well. So if I set that to like exactly 0 is kind of pointless, but if I set that to like 0.029, we can see that we again have a very, very slight wispy fog effect, because each of these layers of fog is being drawn with a very low transparency. If I set this to something much higher, then that's going to come back to something that looks like, as I called it before, packaging peanuts, or perhaps like pillow stuffing or something like that. It's funny, I'll give it that, but it's probably not super useful as a fog effect. Maybe something like 0.15 would be a good compromise here. And lastly, we have the fog layer spacing. So I didn't really draw attention to this, but at 16 layers of fog that are being drawn at varying heights like this, you kind of start to see a little bit of banding, especially in areas where like it's very slight and it starts to cut out like this. And you can still see, with just 16 layers of fog, a lot of like discrete cutoffs with the like the semi-transparent layers that are being stacked on top of each other. This looks a lot like something you might see as like a topological height map or something like that, with the like discrete height layers and that kind of thing. So if we increase the layer spacing, that problem is going to be a lot more pronounced. And honestly, this looks kind of cool in its own right. I don't dislike this, but this, like, if I come over here off the side of the map, especially, you can see the like the height map sort of effect here. But it's probably not something that's really going to be a very desirable outcome in like every game. So I'm gonna say probably in most games you're going to want your fog layer spacing to be a lot smaller. If I set this down to something like maybe 0.5, about half of what we had before, and if I walk back over to the was it over here to the low fog section where we were looking at before, the banding is a lot more, you can still see it, but it's a lot like slighter, and it's a lot harder to see around things like the edges of other objects, whereas you might have noticed it before. And if we increase the if we decrease the fog layer spacing more, we can see that the banding goes away almost entirely. If I were to also decrease the layer alpha because we have more layers being drawn, when we do this, it now looks a lot more like some kind of foam or some kind of heavy, well, you know, clouds or fog hanging close to the ground, some kind of weird like vapory fluid. And if we were to make this scroll or otherwise transform, it would look a lot more like that even. I think this is a lot of fun. Personally, you can play around with these values endlessly to see what you get. There's even other ways that you could modify this. Like if you wanted some kind of hard cutoff with a like minimum brightness, minimum fog value or something like that. Or if you wanted to quantize this in other ways, you could have some fun. Let's see. I'm going to set my default values to something approximately sort of similar to what we had before. So our fog layer spacing was like 0.25 and our alpha was like 0.2 or something like that, I think. I should have copied down the values before I like quit. Yeah, something like that. All right. So I did say that this would look a lot more fun if it was scrolling somehow, and I'm not going to, again, really work with like dynamic fog or anything like that, but I am going to introduce a fourth uniform vec2 u_fog scroll. So this is going to be a vector 2, which is going to be a horizontal and a vertical scroll of the fog. I am going to just simply add this on to the texture coordinate to the varying from the vertex shader texture coordinate, and we're just going to add a scroll over time effect. And that's going to be another uniform, which I'm going to add, let's say u_fog scroll. And I think the way that I did this in the demo was to take the current time built-in value of GameMaker, which is the number of milliseconds since the game has started, divide that by 1,000 to get the number of seconds since the game has started, and then just like divide that by 100 again, so that we have, since this is going to be a scroll amount in texture coordinates, if we divide that by 100, it's going to be a much slower scroll than like one full texture repetition per second, which is probably a little bit overkill for what we're doing. So let's set the scroll amount. I'm going to set that as a vector 2, the same value on the horizontal and vertical. If you want to, you can play around, make the fog scroll in different directions or something. And if we run the game now, we are going to have our fog just moving. So if I were to just sit here for a few minutes, we could see that the fog is sort of rolling along with us. If we sit here for long enough, we will start to notice that the, I actually don't remember if the texture repetition is turned on by default. It looks like it's not. So if you sit here for long enough, you're going to start to see the edge of the fog, and it's going to cut off in a weird and probably not very good looking way. We can enable texture repetition, GPU set text repeat, set that to true, and that is going to have the fog repeat nicely, at least until the value gets big enough that floating point noise starts to become a problem, that sort of thing. If I were to run off towards the edge of the fog, I don't remember if I actually made this texture repeat, made this fog image repeat. But it looks like it actually is, because I'm not seeing actually... Is that a seam? That might be a texture repetition seam. That could also be because I, for some reason, saved the cloud noise image as a JPEG, and there's like aliasing around the edges or something like that. But anyway, that's scrolling fog. Now let's talk about performance. So there's a couple of really obvious ways that I could fix this, right? So some of these... 3 out of these 4 uniforms don't actually need to be set in every iteration of the loop. That's not really going to be a performance bottleneck, because just setting an individual uniform when you're already setting this one over here is not, like, super expensive. But if it just bothers you that you're setting the same value every single time, then you can easily farm this out. It is also possible to, instead of setting a uniform for the ground fog height, to just pass that in as a varying from the vertex shader. So I can set in the vertex shader a varying float v_height or something like that. And we can say v_height is going to be equal to the input position.z. And then in the fragment shader, we can take that. And instead of taking the uniform height, we can use the varying height. So that's going to just be getting the value from the vertex shader. And that's going to look exactly the same as it did before, but we're just going to be completely free to just ignore... Oh, I already deleted it here. We're just going to be completely free to ignore GameMaker, the u_height. This should look the same. And it might perform infinitesimally better because we're just cutting out a couple of uniform sets inside the loop. Alright. Well, we're cutting out all of our uniform sets inside the loop, I guess you could say, because GPU set depth is not a uniform set. So, it is possible to optimize this further by taking the u_max height uniform, and instead of doing this division in the fragment shader, we could also just do this division in the vertex shader. Like this, we could make this a vertex shader uniform.
Hey.
And we could divide our input position by the max height in the vertex shader, and then that's going to be interpolated across each triangle, and you're going to be able to just skip this operation in the fragment shader. And again, this should look the same, might perform infinitesimally better. This is, as we're going to see later on, not perhaps an effect that you really want to do on a cheap low-end graphics card, unfortunately. And for that reason, there might be better ways to implement this effect that I'll talk about perhaps in a future video. So that's going to be the low-hanging fruit that we can optimize out of the shader code that I wrote here. Now we can talk about performance. If I sound different than I did about 5 seconds ago, by the way, I re-recorded this part and the springtime allergies are hitting me hard, so now I sound like I'm dying. So I said in the sprite stacking video that sprite stacking is a uniquely expensive effect because it hammers both the CPU and the GPU for different reasons. The reason that sprite stacking is expensive on the CPU is fairly obvious. For each sprite stack you draw, you have to draw potentially dozens or even hundreds of individual sprites, and that does add up over time. And the reason that sprite stacking is expensive on the GPU, I said I would save for a later date when I could put it in somewhat better context, and that later date is now. So the problem of overdraw in computer graphics happens when you draw, let's say, for example, a polygon, and you rasterize it, you figure out which pixels in the frame buffer it covers, and then you run the fragment shader on each of those pixels in the frame buffer. And then let's say that sometime later you draw another polygon, again, potentially a very large polygon, and it covers exactly or almost exactly the same space on the screen. And that can lead to, if the new polygon is opaque, then all the work that you did previously is just going to be completely wasted because you won't be able to see it. And if the new polygon is semi-transparent, as is the case with this ground fog here, then the work that you did on the previous pass on the first polygon is going to only contribute a small amount to the overall look of the scene. Now, overdraw isn't something that you really have to worry about often in GameMaker because you don't usually do things that would incur this very often in GameMaker. Like, it's not a problem if you have a couple of background tile layers and then you draw a couple of foreground, like, trees or players or NPCs or whatever on top of it. That's not really what concerns us when it comes to overdraw. What concerns us is when you have a large layer, for example, this ground fog that covers most of the screen, and you have to draw it over itself many, many times. So in this example here, if I run this, we have a ground fog effect with a max height of 32 and a spacing of 0.25. So there's going to be about 128 individual layers of fog that are going to be drawn here. I want to say that's going to be 124 exactly because we're offset from the ground by a little. And this isn't going to hammer the frame rate too hard. But if I were to increase this, if I were to decrease the spacing, rather, then I'm not going to say this doesn't look good. This does look very convincing as a fog effect, but if we set the spacing to 1/10 here, we have just under 320 layers of fog that are being drawn, and these are all covering most of the screen. It'll extend about 2/3 the way up the screen and then stop because the near clipping distance is going to cut it off at that point. And if I look at my task manager and if I look at my GPU utilization, we can see that on my short GTX 1060, we're bouncing somewhere between about 20 and maybe 40% GPU load when we draw this effect. And again, this effect does look good. I'm not going to say it doesn't, but for a scene like this, you wouldn't expect it to consume between, say, a quarter and almost a half of my entire GPU power. And much like how in the previous sprite stacking video, we were quickly adding up thousands and thousands of individual draw sprite calls. When you draw ground fog like this, it's very easy to have the number of large, mostly transparent polygons adding up quickly over time. And I know better than to try to cite an exact number regarding how many layers of ground fog is too many, because then people are just going to repeat it without context, and it'll probably end up becoming one of those things that people say on the internet that doesn't really have any meaning. But the point of all this is that if you want to do an effect like this, be mindful of how heavy it can be. Like I said at the beginning of the video, there are other strategies that I've seen pertaining to ground fog and to fog and clouds in general. And I'd like to make videos about how they work at later dates as well. But that's going to be a future me problem. I'm going to end this off here. My name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the description of the video. Let me know if you have done something like this in one of your games on your own, or if you do prefer some other implementation of ground fog. I like to post videos on weird stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff, which, incidentally, does not feature ground fog like this, although one of the other games that I'm working on does. And it hasn't been officially announced yet, but I'm hoping that they do it soon, because I would like to actually, finally get to record gameplay on it. Anyway, I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Manta Ray, Ganymede Ghosts, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you'd like to join their ranks, head on over to the Patreon page down in the video description to join the fun.